Hello YouTube, it's been a while since I made my last video. That is mainly because I couldn't find any video idea to make, so yeah, kinda have to deal with it. That was until today I came across this little pump online while scrolling through local marketplace. I ended up purchasing it with a plan on modifying it for something else, which I couldn't remember what right now. But after it arrived, I tested and take it apart a little bit and discover something interesting that I think might worth showing in a video. And with the style of a YouTube channel known as BigClive.com. This channel. So yeah. But yeah, I don't have the exact same camera angle and stuff, but I'll do it my own ways, but inspired by the channel. So here's the pump itself. It's an XG668A. It says advantages are large air volume, inflator or deflator. Oh yeah, this thing is designed for those airbeds and those inflatable pools and stuff. It says quiet operation, safety circuit. We're gonna test that. Wide voltage support, 100 to 240 volts at 50 and 60 hertz. But this is not what I'm looking for. It's on the side. I don't know if you can read that, but I'll read it for you. It's a product name multifunction air pump. Product number is XG668 again. Input 100 to 240 volts AC, 50 or 60 hertz, or DC 12 volts. And the output is 400 liter of air per minute. I don't think it will do that much, but I'm not very experienced with airflows and stuff. So yeah, it says the size, the function, and inflate or deflate items. So this is what I'm going for, the 12 volts input. So this cable connects to my audio interface so I can monitor the recording. So yeah. I haven't been able to find a way to put it aside because it's just too short. Just look at this. So now let's take a look at what's inside. This is not how it's configured from the factory because I've kind of opened it and not sure how to put it back together the proper way. So yeah, it comes with 3 nozzles, a small power adapter, and the pump itself. Now let's take the box aside. Oops, what is that? And now let's take a look at this power adapter. It says input 100 to 240 volts AC and the output is 12 volts 2 amps. Now, here's the thing. The box doesn't say the power rating of this pump. But I believe on the online listing it did says the power rating is 120 or 150 watt, which is somewhat similar to the other version of this similar pump that I used to have at some point, but it's an entirely different design inside. I didn't take that one apart because it was all glued shut from the factory, but I can tell what's in this thing on the other version is it's a universal motor. So it's probably not as hard to reach 170 watts with that. And this is like rated like, does it say here? No. It doesn't say any power rating on this thing. Now let's take a look at what's inside this pump. Where's my, oh, here it is. It only have 2 screws holding the back cover, and the front is, I believe, ultrasonically welded from the factory, just because it's cheaper or something. Oh wow, the screw is still stuck. There it is. Now opening it, it have a hairdryer style motor inside. Oh, I don't have my caliper with me, but What's the size of this? It's like less than, I believe it's less than an inch or something. I might add it to the video later. So on first glance, I think, yeah, it runs at 12 volts. Why not? I know I have worked with this style of motor before. So yeah, I didn't suspect anything. Let's put it back together for now. Okay. Now let's turn it on. Oh yeah, the adapter comes with this kind of barrel adapter. I believe that's what it's called. Now let's turn it on. Also for headphone user, this might get loud, so might consider turn down your volume. It works. Now what is interesting is that I can feel the air flowing. Let's put it aside, like a distance away from the mic so I can still talk. Now, if I cover this up and stop any airflow, the motor gonna get less load. That's interesting. I'm like, oh wait, that is interesting. Did they really overload this motor to the point that under load it slows down so much? Could it be? I didn't think much about that after that, honestly. And then I got an idea. How about what if I run this off a battery? So I prepare my lithium ion battery, the battery pack that I made myself. It's 3S2P. Now let's plug it in and see what happened. What? Hold on a second. Is my battery faulty? Is my battery faulty or something? It says 12 volts. It's not supposed to be that slow. Now let's get my multimeter and measure the battery voltage. So yeah, my camera is not exactly at an optimal angle, so it's kind of difficult to see the meter reading. I believe you could do this with... Oh yeah, you can. Oh, it's 12.11. Why is it so slow? It's not the battery's fault. Now let's see what voltage did this adapter put out. There's no way it puts out more than that, right? It says 12 volts 2 amps right on the sticker. So where's my connector? That one thing? Where's that one thing? Oh, here it is. Let's connect the adapter directly to the multimeter and see what voltage it puts out. There's no way it says 12 volts if it puts out more than that, right? This is just an adapter. Plug it in. And plug it in. What? Whoa, something funky is going on here. Also, this is a 220 volts mains, so the rectified DC is around 300 to 350 volts. Why does it put out 300 volts? It's not supposed to do that. Okay, let me unplug this for now. Let the voltage drop to safe level. I don't want to touch this. Even though it's still low voltage, but like, it's not good thing to touch. How did this thing put out 300 volts? How did that small motor handle the 300 volts? Now let's put the battery aside. And put this aside. Now I'm curious. So I take my flathead screwdriver and open this adapter. It's hard to open. But inside, it has such a small module. A tiny board for 2 amps rating. I have a like, what is it? 5 volts, 2 amps that is like a lot bigger than this board. So let me check the main capacitor if it's fully discharged before I touch it any more than I already did. Oh, that is safe. It's 1.2 volts. Now taking it out, it have a transformer, but this is not the design of a standard SMPS. And those who watch what is it? Oh my god, I couldn't. For those who watch BigClive.com's video will know this is a very familiar board. It's a buck converter for an LED light. Is it? I'm not sure. So I look at this small DIP 8 package that only have 7 pin. So should I call it DIP 7 or what? I don't know if there's a proper name for it, but like, yeah, let's just call it DIP 7 or whatever. It's a BP something. And I've heard that 2 letters often. I believe it's called Bright Power or something. Now let me switch to a different scene. Now this is the datasheet on the chip itself. It's a BP2867XJ. It's a non-isolated buck offline LED driver. It was designed for LED. So this board. Where is it? So this board is designed for LED lights. It's a constant current driver, and it's non-isolated. So everything here. This is mains reference. You could get the shock from this. Now, this does works, but this could be dangerous. Okay. Honestly, I personally don't think the circuit itself is dangerous if it's used properly, because it was designed to be inside an LED light that is fully isolated. Since you cannot touch anything unless you modify it or open the cover to do something with it. Let me put this together. So like they use it incorrectly, and this could hurt someone. I mean, we all used to just grab any other adapter when something fails, right? I remember I've grabbed like, what is the thing that use power adapter a lot? What is it? I couldn't figure it out. I believe I used to have, what is, I don't remember what it is, but long story short, the adapter that come with it fail. And it's an easy fix. You just grab any other adapter that have the same rating. Pretty much same voltage is what's important. And any current that is the current rating that is the same or higher is fine, and it works fine. Also note the polarity. There are some evil connection out there. Not exactly evil connection, what do they call it? Evil adapter. With center negative. That is the most annoying thing ever exists. But yeah, you wouldn't want to grab this and plug into your other expensive stuff. It will blow up. Now, how did this tiny motor take 300 volts? As we have seen on the datasheet, it says a LED driver. So that is gonna be a constant current driver. Oh wait. It actually say DIP 7. So yeah. My random guess is true. Now let's measure the voltage when this operates. I don't think I should use the 2-pin Wago connector for this. Where's my bigger one? So I can clip my multimeter in it. Let's use the 5-pin one. Let's make the connection. Put this aside because we don't need a battery connector. We're gonna keep this plug. Yeah, this is too short for a Wago, but it works just fine. It's not gonna be a permanent solution. I'm gonna removing it when I'm done with this, so yeah, don't need to point it out. Put it in. Where's the cable? Which one's positive? Okay, this one have the line. I've checked this one. The cable with lines the positive, so let's connect it to the positive and negative. Connect one side to there. This side connects to the adapter. Okay, 1 second. That's the best visible I can do. Plug it in. 301. Let's turn it on. Again, it might get loud. Oh, it drops to 47 volts. Now what happened when I cover the airflow? The voltage go up to 68.1.2. Now when I release this, it goes back down. Why does it do that? The answer is with how this power supply works. Now let me grab my clamp meter to measure the current. Set it to DC. Yeah, the magnet in here is messing up with my meter again. Is it visible? Let's grab something to prop it up. Should be good enough. Let's turn it on, see what happened. It's not 0.51 amps. Essentially 510 or 520 milliamps. Should have made it 420. But when you cover this, the voltage go up, but the current stays the same. So essentially, when we remove the load on the motor, the motor gonna take more power, more than what we have when the motor is under full load. Let's do a calculator. Oh, my keyboard is upside down. Where is it? Where is C? Oh no. Now let's open calculator. Now, as we know from the measurement, the motor will pull 500 milliamps no matter what. So let's put 0.510 or 520 multiplied by, under full load, it's like 46.5, I think. It's pulling 25 watts. Nowhere close to the rated, to the 120 watts that was written on the seller's listing. Now let's clear. 0.52 multiplied by 68.2 volts when it's with no load. It pulls 35.6 watts. not meant for 6 watts. So I'm not sure what goes on with the design of this, or they just try to make it as cheap and it works as much as possible. But this, not the pump itself, but the adapter could be dangerous if you unknowingly use it for something else that you thought it was just another 12 volts adapter, and you plug it into, for example, like your computer stuff, like what? Usually a modem or something like that will use 12 volts adapter or 9 volts. So if you have a multimeter, make sure to check the voltage before you plug things into other stuff, because who knows what you're gonna blow by doing that. I think that's all I need to cover. Alright, that's it. Thanks for watching. See you next time.